So, and yes, I am rocking the socks and Crocs. The socks and Crocs. I did steal these from my son. These are his Crocs. He's 11. Alrighty. So we're going to work with, there's a problem like this one on the homework that we never did one like it, so I wanted us to do one very much like it. Find all points on the y-axis that are a distance of 6 from this point.
Wait, where was the homework? I didn't see it.
The yellow paper that I handed out, that's up there.
You didn't put it on the board. You didn't put it on
maybe if you were on your phone all the time.
Was on the board yesterday for sure. That's this yellow paper. The homework is right there. Tomorrow. Yeah? We have homework every day, y'all. Tomorrow, because we're still going through stuff. It's there. It's there. The list is there. The pages are there. They're there. You got to look at Unit 2. Chapter 3, Unit 2. It's listed as today, but we're still talking through some stuff, so if we have some that we didn't quite get to, it's okay because it's tomorrow. Yeah, totally fine. Okay, because there's a problem like this on the homework, and we haven't done one quite like this. I try and always hit one like them all. So this uses that distance formula. Yes,
What about this that we drew yesterday?
We're going to do that next. I was just tossing this one in there. We'll hit the midpoint formula next, and then we'll get into what we're really supposed to be doing today. So our distance formula, remember that's the distance between 2 points. It's like you should have this one now. This is the difference between the x's squared and the difference between the y's squared. This guy? Yeah, we've been using this one for a couple of days now. So what we're doing is we're finding a point on the y-axis that has a distance of 6 from that point. So I have 1 point, I have a distance, and I know it's on the y-axis. So we're going to plug some pieces in. The distance is 6. One of my points is 5, 3. So we can do x minus 5, y minus 3. So we can plug pieces in that we see. And you don't have to put the little ones underneath now that we just have an x and a y. I also know what's on the y-axis, which gives me one more piece of information. What does that tell me? My x is 0. So we know 6 equals the square root of 0 minus 5 squared plus whatever the y is minus 3 squared. Because it's on the y-axis. Because it's on our y-axis, so that means it's our y-intercept. So my x is 0. Yes, dear. It does not matter if it goes in for x1 or x2. What was the question over here?
What if it was the x-axis?
Then the y would be 0. Yeah, if it was the x-axis, the y would be 0. If it's the y-axis, the x is 0. Yes, dear. Because it's on the y-axis. Because they told us that. So I know it's a y-intercept. So x is 0. So all we got to do is find the y value. How can I get rid of that square root on the outside? Square both sides. There we go. So we square both sides. And we get that 36 equals 0 minus 5, so negative 5 squared, plus y minus 3 squared. Already slightly less gross. Yep, back up. So that's the first line we plugged in. Just try to make things big enough so we can see, right? What can I do down here to simplify this? It's not y squared minus 6y. We have multiply it out. We got to get the whole thing. You had 2 of the pieces. We got to catch them all. So we've got our 25. And also do not tell me it's y squared minus 9. I had a significant number of people do that on the test where we squared this and missed the middle term entirely. So you can box it, you can write it out, distribute it. I don't care how you do it. We should have y squared minus 6y plus 9. All 3 pieces. When you square a binomial, you get a trinomial.
How do you do the middle piece with the shortcut? Like, how do you do that?
So you practice it a bunch, or we do y minus 3, and you distribute.
I know you could distribute.
Or you can box it.
I know.
I don't care how you do it, but you can't skip the middle term. I had a surprising number of y'all forget the middle term existed. So let's simplify the right-hand side. I've got some like terms we can combine. 36 equals y squared minus 6y plus 34. We have a quadratic type equation here, which means I need to set it equal to what to be able to solve it? 0. Subtract 36 from both sides. 6y minus 2. Can we factor it? Really?
It's y squared though.
No, we can't. This will not X and box. Quadratic formula. There's nothing that multiplies to be negative 2 and adds to be negative 6. So we're going to have y equals, instead of x this time, the opposite of b. So opposite of negative 6 is positive 6. Plus or minus the square root of b squared. So negative 6 squared. 36 minus 4 times a times c. 4 times 1 times negative 2. Plus 8. Over 2 times a, 2 times 1, 2. Y equals 6 plus or minus the square root of 44. We gotta simplify it. Y equals 6 plus or minus 2 square root of 11. Because we're going to divide the 4 out. 4 times 11. Square root of 4 is 2. Over 2. Can I simplify it further? Yes. Y equals 3 plus or minus square root of 11. Because the 2 cancels out. So the y values of this point are 3 plus square root of 11 and 3 minus square root of 11. We are not getting decimals. That is that's going to be it. That's it, is what it is. It's gross, but it's there. So there's at least one on the homework like this where it asks you to find the points, or at least the y values of the points that are some distance away. Questions on this one, because these ones are beasts. They're real long. The midpoint ones are not as long. But I wanted to make sure we saw one like this too. Ready for me to change it? All right, so most of us wrote this down yesterday. The midpoint formula. Lock it in, y'all. What we're doing to find our midpoint is you average your 2 points. Add them together, divide by 2. Add them together, divide by 2. Add the x's to get the x. Add the y's to get the y's. We're looking for a point. What it does is it finds that midpoint. It does not matter if your line is angled or straight. It genuinely does not.
Is this unit 3.2?
Nope, this is still 3-1. I will tell you when it switches to 3-2. I promise. We're going to do 2 midpoint problems, and then we'll be in 3-2.
So tomorrow we learn the 3-2 and the homework.
We're going to start 3-2 in 2 more slides,
Oh, okay.
because we should have started it today.
Okay.
But we kept running out of time. So what we're going to do is we're going to find the midpoint of this segment. Thank you. Yeah, Vanessa. You got something to pick up? Yeah. Yeah, that's fine. All right, so finding the midpoint, it's just using that formula. We are given the endpoints of a segment, A and B, and we are looking for the midpoint. So to find the x value of the midpoint, we take the x values, 7 plus 3, and divide by 2. So 10 divided by 2. Oh, they just sent a pass down for her to come and get it. Oh, okay. You have to sign for it. It's apparently UPS. So she's... Yeah, she needs you to sign it. She got it. All right, so what is the x value of this midpoint? 5. So this is for our x value. We do the same thing for the y's. We're going to average the y's together. -3 plus -8 and divide by 2. -11 over 2. So what's the y value? -11 over 2. That says x val. That's because what this is we're finding the ordered pair for that midpoint. It is 5, -11 over 2.
Why did you change the -3 to a positive 3, but you didn't change the -3?
I didn't change the positive 3 to a -3. I took the x values and the y values.
Alright. I know. I thought.
Yeah. What's up?
No, I'm on 63 and 7.
Well, maybe you told us this.
Okay.
You got above average.
How we feeling on midpoint? Because we're going to do it the other direction in just a second. Midpoint, we find the average of the 2 points. We remember it's scarier than it is.
Yeah.
So the other type of problem we'll see on the homework is they're giving us a segment of AB and point C, and they're telling us A and C, we have to find B. So we know C is the midpoint. Sorry, dodging. So the way we set this up is really, really similar. We remember that the midpoint we do by averaging the 2 points together. We know that A is -4, 6. B we don't know, so we're just going to call it X and Y. So to find point C, we would take the X values. So for our X, we do -4 plus X divided by 2 gives us the X value for C, which is 1. I've lost several of you there. You see it? Midpoint formula, plugging in for a value I don't know, but this time it's inside the formula. This one. It's this X, and the 1 from my midpoint. So let's solve it through. How do we get X by itself? Multiply by 2. -4 plus X equals 2. So what does X equal? What do we do to get X by itself? Add 4. X is 6. We do the same process for the Y's. We take the Y value from our point, which is 6, plus the Y value from B, which we don't know, it's Y. Divide by 2. And that's going to equal the Y value from C, which is -3. So solve this one. Multiply both sides by 2 again. 6 plus Y equals -6. So what does Y equal? -12. Watch those signs. So our point for point B is 6, -12. That is the point that makes C the midpoint. Okay? So now you've done problems like all the ones on homework 1. And now we're going to look at homework 2, which is going to be a lot of graphing. So I'm going to put a small pile of graphs on every table. So if you need graphs, you can have them. Because we're going to do as many as we can today, so I'm not going to count them out just in case I go over what I named you the first time, and then I just have more in. Stack. So we're going to do as many graphs as we can. I don't know. It depends on how many we get through. We're going to go through as many graphs as we can. So first thing we're going to remember is how to graph a line. Middle of the table. I put stacks down. They look like bookmarks. There's a whole bunch of them. There's a whole bunch of them because I don't know how many graphs we're going to get through. We're going to get through as many as we can. And I don't want to have to pass more out. They are set up so that you could just glue them in as a bookmark. But if you want to cut them apart, that's on you. As many as you need. I don't know how many we're going to need. That's why I put stacks out. We're going to keep going until we run out of time. So, graphing lines you've been doing since probably 5th grade? Y equals mx plus b, we've seen a hot minute. Long time we've seen y equals mx plus b. What's this one called? What's y equals mx plus b called? Slope intercept. It uses our slope. And our y-intercept. What are you looking for?
It does not have to be that big though.
The bottom one has at least one piece the same. M is still our slope. What this one is called point slope, if we don't remember that. Because inside this equation is a point. X1, comma, Y1 is a point. It gives us a point, it gives us a slope. We can get a line. So we have two down here at the bottom. We're going to graph them both. If you want to put them on separate graphs, you can. It's just more cutting and gluing for you. I'm going to put them on the same one because it's lines. We're familiar with lines. So we're going to graph y equals minus 3x plus 2. Where are we going to start for this guy? For minus 3x plus 2, where am I putting my first point? 0,2. Yep, my y-intercept of 2. Right there. How do I move? How do I get my next point? Down and to the right. Down 3, right 1. Down 3, right 1. Or you could go up 3, left 1. As long as you only change one direction, we still wind up with a negative slope. It should look like it's going downhill. The more points you have, the easier it is to connect them up. Yes, you must use a ruler. Yes, there will be points taken off if you don't. For straight lines, you have to use a ruler. Or the edge of a piece of paper, or the edge of a ID card. Huh?
What if you use a ruler and it's not straight?
I can tell that you've used a ruler and you're not freehanding. Like if we sneeze in the middle of a ruler is way different than freehanding a line. It's a way different vibe. I can tell. There should be rulers at almost all of the tables. They should be in the boxes. There's several rulers out and about. If you need more, they're behind surfing cap. Or you can use the edge of your notebook, or the edge of your ID, or the edge of your phone, as long as you don't use the side with buttons. All right, we're going to graph this other line as well. When we have our point slope form, we're going to pull the point out of it. The x value of the point is 2. The y value of the point is 3. And our slope is positive 2. So we start at that point, start at 2, 3, which is this point up here. 2, 3. And then we use our slope of 2. Up 2, right 1. Up 2, right 1. Up 2, right 1. Or you could go down 2, left 1. I don't care which way you go. Just plot points. The more points you plot, the easier it is to connect them up. If you only do 2 points, especially when your slope is really close together, like slope of like 1 or around 2, it's really hard to get that ruler straight off of 2 points. The more points you have, the easier it is to plot them. You can do them on the same graph, or you can do them on different graphs. It's just 2 lines, so I was just going to do them on the same graph, just so 1, you had less cutting and gluing, 2, I didn't have to clear my screen. Yes, Jay?
So how did you get the 2 and the 3 for the point again?
So we pull them out of the point slope form. It's this y1, x1 from our formula up here. That's where we're getting the point from. Because the formula has a minus sign, our points are positive. Positive 2, positive 3. Okay, it's been a hot minute since we saw point slope form. That one is not as frequently used. Slope intercept form is a lot more frequently used. And if you want to, you can always take it and multiply it out and be point slope intercept form. Totally fine. We would have distribute the 2 and then add 3 to both sides. Get it in slope intercept form. That's a valid strategy. We are not just going to be graphing lines, though. Start either at your intercept or your point, and move with your slope. Okay? Are we ready to move on from lines? Or we got questions?
Why is that one? Is that because there's nothing on that side? That's why the x slope is 1.
Wait, this 3.2?
For y equals negative 3x.
So for this guy, so it's positive 3 because our formula is y minus y1. And our slope is 2 because that's m. And that's a positive 2 because, again, our formula has x minus the extreme point. I just did them on the same graph to save myself from clearing the whole screen. Yes, dear? Because our formula has x minus up here. Okay? Because we're going to remember how to graph a whole bunch of other kinds of stuff. Ready? Breathe. Okay? It's always a little scary when I say ready several times before I turn the page, huh? I know. We're going to remember how to do quadratics. We're going to remember how to do cubics. We're going to remember how to do square roots. Because they all play together. Quadratics, cubics, and square roots. And we're going to be working with A and K. We've worked with A, H, and K for a long time when we're graphing stuff. For our transformations, we're going to be doing A and K right now. Sometimes you'll see it written as A and C. A is when we do stretches and compresses. K is when we do a vertical shift. Same jobs they've had for forever. But right now, we're just going to graph the parent function of quadratics. The parent function of cubics, the parent function of square roots. Parent function just means it's going to be the basicest of basics. No transformations on it. We're just going to do x squared for our quadratics. The parent function is y equals x squared. When we're doing parent functions, we're often going to want our parent table where we pick x's and plug them in to find y's. We're going to do more, we're going to do as many as we can. I've got 6 more pages with graphs on them.
6 more pages?
Yeah, we're going to be graphing a lot.
Y'all need more graphs?
If you need more, dude, this is the stack I made for us. There's 3 on each of these sheets. I mean, you can. I was gonna say I also can get you graph paper. You need more? I got you. All right. So when we're doing parent functions and we need that good view of the center of our graph, what x values do we pick? 0 is a good one. -2, -1, 0, 1, and 2. Always give us a really good view of our middle. I'm just writing it down here at the bottom. What is -2 squared? What is -1 squared? What is 0 squared? What is 1 squared? And what is 2 squared? 4. That's our parent table. You should have written that for quadratics. That should be very familiar. You've written it about 1,000 times in Algebra 2. Yes. Okay, we're going to plot those points.
Hello, Kitty?
What? Why are you talking Hello Kitty?
No, because it was like 8K. It was like HK and stuff. Like
Okay. I don't know how that relates to Hello Kitty. Oh, Hello Kitty. There we go. Now I hear it. But I'm just like, huh? Okay. Got it. I hear you. Plot those points. So we should get this as our shape. Quadratics look like this. U-shaped. X squared is always U-shaped. We are going to do the same thing for cubics. Use those same X values. We're going to make a new parent table to look at these transformations. A, H, and K we've used for a very long time. We pick our X values to find our Y table. Find the Y values. For X, we're going to do -2, -1, 0, 1, and 2. What is -2 cubed? -8. What is -1 cubed? -1. What's 0 cubed? 1 cubed. 2 cubed. 8. So we get our basic cubic. Because -2 times -2 times -2. So cubed. 1, 2, 3, 4, 5, 6, 7, 8. It's way down here. This, like this, like this. Like that. It's kind of S-shaped. Our basic cubic kind of looks like that. It's been a minute though, right? It's okay. That's why we're going through it, so we can remember it. Then we're going to do the same thing for square roots. When we do square roots, are we going to pick those same X values? Why not? Because they don't square root pretty. And can we do square roots of negative numbers that we graph? No, because we can't. We're not in an imaginary plane here. That is a thing.
So we do 1, 0, 1, 2, 3, 4, 5, 6.
So you can do 0. Let's pick things that will square root nicely. 1. What's the next number that square roots nicely?
2.
What's the square root of 2, y'all? 4.
4.
What's the next one?
16.
9.
I was like, you can't do 16. My graph don't go up to 16, but you can do it. All right, what's the square root of 0?
0.
Square root of 1.
1.
Square root of 4.
2.
Square root of 9.
3. Got it.
So plot the points. It looks kind of like half a parabola turned on its side.
More graphing?
Yep.
I think it's time to go though.
No. We still got time. So these are our basic parent functions. 38. What's that? All right. Breathe. Okay. Put it back. Because we're going to talk about transformations. We're going to be using the A and the K that we have in these little formulas here to make our transformations. We've done it before. It's not new. We're just, doing it faster than before. So think about what we remember for A. What do A transformations do? It can do a flip over the which axis? Over the x-axis, so it's a reflection over the x-axis. What else does A do? Compress and stretch. When does it stretch? Greater than 1. It's a big kid does big yoga, gets really tall and skinny. When it's between 0 and 1, it looks like somebody sat on it. It gets squished. Because it's so little and cute, I want to squish it. That is the easy way to remember which way it goes, because it's really hard to remember which way is stretch, which way is compress. A vertical stretch goes up and tall and thin. Big kids do yoga. Big kids do yoga. People were mad when I changed the slide, so I was just starting to talk while people wrote it down. So A does a vertical stretch or compress. Stretch is when A is bigger than 1. Compress is when it's so little and cute, I just want to squish it and it looks like somebody sat on it. H does a horizontal shift. H horizontal or hula. I am genuinely not afraid to do something ridiculous to make y'all remember. Oh, just wait till we get to asymptotes. K is a vertical shift, up or down like a kite or a kangaroo, but kangaroos I feel like travel significantly more horizontal and I don't like it. So kite is how I think of it. K is a kite, up and down transformations. H is a horizontal shift, left to right. We're not going to do much with H today, but I didn't like talking about A and K and not touching on H. And A is our vertical stretch or compress, or reflection over the x-axis. Reflection over the x-axis happens when it is negative. I thought I lost my goober, but I didn't. Okay, so we're going to start with y equals negative 2x squared. So what transformations should this have? A vertical stretch and a reflection. The way we are going to do this is we're going to take our parent table, which I'm doing it vertically this time because I have actually space. That negative 2, negative 1, 0, 1, and 2 that we just wrote. With our x squared, it was 4, 1, 0, 1, 4. When we're doing our transformations, we are going to be taking our x values from our parent table, taking our y values times A plus K. Yak. Y times A plus K. When we get to H, we'll do x plus H, y times A plus K. Should be hopefully familiar. X's, right now we're just bringing them over. We don't have any H transformation. On this one, all I have is an A of negative 2. So we're going to take 4, my y value from over here, times the negative 2. What is 4 times negative 2? Negative 8. What is 1 times negative 2? Negative 2. Negative 2. No, positive 1. It's our x's from this column, just plopped over here. Now I'm taking the y's and times A plus K. So I'm taking, give me my laser pointer, this 0 times negative 2. 0. This 1 times negative 2. And this 4 times -2.
-8.
There's our points. -2, -8. -1, -2. 0, 0. 1, -2, and 2, -8. If we connect them up, we can see that this has indeed been reflected across the x-axis and vertically stretched. So we are going to do, and this is true with all of the nonlinear functions. We'll do x plus h, y times a plus k. It works for everybody. No matter what our parent function is, as long as we can find a and k, we can get our tables. We take that parent table we just made and put it up there. And this stop y'all from complaining. Here's 3, 2. Yep. Yellow paper has them all listed out, and you don't have to try and sneak a picture. Or it's on the module page. 3, 2 is not due tomorrow. It's listed as Friday. Probably it's going to be more Monday because we're probably not going to get through everything
When's 3, 1 due? Tomorrow or today?
tomorrow. Because we didn't get through everything until today. So once we get through all of it, you get the next day. What's up? Yeah. Have a great rest of your day, folks.